topics I could do. And we could do one of them or both of them, depending on what you guys want. So the first one is kind of a very basic introduction to MongoDB and how to use it with Perl. And the second one is, I think, the more interesting one, which is a kind of brief tutorial of the MongoDB aggregation framework and some interesting things you can do with Perl and MongoDB aggregation queries. So which of either of those sound interesting, or do you want to do both of them? I'm leaving it up to you all.
How many people have used?
They're both fairly short.
Oh, well, if they're short and you want to do both, that'd be great.
Yeah. All right, let's do it.
Both is always a good answer. Set this up over here.
In a few minutes, we need that.
So, how many of you have played with MongoDB a little bit, or used it in production? Anybody?
Not production, but
Not production, but you played with
I've
it.
done stuff with it.
Got the basic idea. All right, so this talk is a very basic introduction, and we're just going to figure out a little bit about what MongoDB is, how you can use it with Perl, what resources are out there for people who want to work with Perl and MongoDB, and so on. So that's me. I work for MongoDB. I drink the Kool-Aid. MongoDB is currently hiring. Unfortunately, not really much for Perl stuff, but if you have other skills, for example, if you are really interested in Go or C++, we want you. We have a lot of internal tooling built in Go as well as also Python. If you're interested in driver development, we have openings for Ruby, Java, .NET, C# stuff as well. So if any of that sounds fun, you can come and talk to me, or I'll give you a card. So what is this thing? MongoDB is essentially a document-oriented database, and we're going to figure out a little bit later exactly what a document is and what that means. But most importantly for us, and raise your hand if you're a CPAN author, by the way. I know a few of you would. So MongoDB is open source. So the database itself is primarily written in C++. It's open source. It's on GitHub. All of the official database drivers that we support about a dozen languages: Perl, Python, Ruby, PHP, Java, C#. You know what else? We have an Erlang driver, which has been unmaintained for a while. We have a Haskell driver, if you're a crazy person. And all of these are open source. They're all on GitHub, and you can look at them and contribute to them if you like. MongoDB is really crazy fast. And for what it does, it can offer very high performance in comparison to doing the same kind of tasks with a traditional relational database. And the reason why is because when working with a traditional relational database, there's this layer that has to sit in the middle where you take things that exist in your table structure and you transform them into things that exist in your programming language, like, for example, Perl hashes or arrays. The nice thing about MongoDB is your data is already in that form. So you give up this idea of normalization, which is really useful in some problems, but not useful in others. And instead, we do what we call document-based storage. And in MongoDB, everything in a document and everything at every level in a document is a first-class data item that we can query on, we can ask questions about it, and we can index it. So we also talk about this thing called horizontal scalability. And there's two sort of orthogonal methodologies when we talk about scalability. And really, because that includes both making things big as well as making things fault tolerant. And so the first level of that is replica sets. And replica sets are similar to what a lot of relational products offer, which is the idea of a master-slave setup. You have a master, we call it a primary, which you can write to, and slaves, which we call secondaries, which are read-only and grab data from the master. So we don't do eventually consistent master-master replication like some other products do. But we have this idea of replica sets, which can be, at minimum, 3 members. We also have this idea of sharding, where you can split your data collection up into several different pieces. And those individual shards can be single MongoDB servers, but what we really recommend for production use is that each individual shard be a replica set. So what you can end up with this structure is things that scale up very, very, very quickly and can really store massive amounts of data very efficiently. And the final bullet point here is full featured. I don't know what that means, but it's in the marketing material, so I put it on the slide. So we're going to look at building a simple kind of demo application, and this is a pretty common demo for database products. We're going to build a very simple library, and the code for this is on GitHub. I'll give you the URL at the end so you can look at the code if you want. And this is the kind of example that you find in a lot of SQL books and database tutorials. I think the first SQL book I read had a CD collection example, which was kind of the same thing. And these are kind of the things that we want to support. We want to have users, we want to have books, books have author information and publishers and so on. So what we're going to need to actually do this, we're going to need the MongoDB module from CPAN. Actually, I should say first we need MongoDB itself, which we get from mongodb.org. We're going to need the MongoDB module from CPAN as well as Modulicious, and we're going to make a simple Modulicious-like application. If you haven't worked with Modulicious before, I highly recommend checking it out. It's really, really fun. So we take a look inside the CPAN distribution for MongoDB. There's a bunch of modules in there. And probably the most important one is this one called Mongo Client. And this is sort of your entry point for working with MongoDB. Mongo Client is going to encapsulate all the information for your actual connection to the MongoDB server, any authentication information that you supply, any replica set information that you supply, and so on. That all happens within Mongo Client. Additionally, there's this one called database. And this is an object that just represents a database on the MongoDB server. MongoDB databases are basically namespaces. So they don't really do much by themselves. You can just use them to separate, logically different databases from one another. The interesting thing, the real meat of the driver is a MongoDB collection. And a collection is kind of analogous to a table in a relational database, but not really. A lot of intro MongoDB presentations like to put this table up where they say a collection is like a table and a document is like a row, but it's really not true because documents are nothing like rows in relational databases and collections are really nothing like tables. But thematically, in a very, very broad and wrong sense, you can think that they're kind of similar because they exist at kind of the same level. When you want to get information from a MongoDB collection, you'll call various query methods on that collection object, and what you get back is a cursor. And the cursor is the thing that talks to the database and grabs the information that you need, in this case, individual documents. So let's look at what an actual document looks like. Documents live in collections. Collections you can think of as a schemaless basket of documents, and we'll talk a little bit about what that means. A document is essentially a Perl hash. So if you're familiar with hashes, then you get the basic idea of documents. There are a couple key differences. One is that documents are ordered, Perl hashes are not. Usually that doesn't matter, but it does come up occasionally when people notice weird things going on. So to deal with that, if you have a situation where you really need something to go into MongoDB in a specific order, you can use tie ix hash to do ordered hashes, and those are supported natively. Documents like Perl hashes can have nested structures. So if we can store hash refs and array refs in hashes. We can nest structures of hashes and arrays as deeply as we want. Same thing in MongoDB. And they look sort of like JSON. They're not actually stored like this on disk. They're stored in a binary format, which we call bson, which is an open standard. You can see that on bsonspec.org. It's actually a really interesting data format if you're interested in that sort of stuff. But when you're looking at it in human readable form, using a tool like the Mongo shell, the document looks like something like this. And this is not exactly JSON because this has types that JSON doesn't have. We have, for example, this thing called object ID, and we also have this thing called date. We're using a native JavaScript date here.
And trailing commas.
What's that?
And trailing commas.
And trailing commas, you're right, that's wrong JSON. So it looks a little bit like JSON, but it's a superset of JSON. And so this represents a basic book, right? So we have the Fellowship of the Ring, we have a language, we have this genre field, which is an array that actually has 2 items in it, and we have this publication, which is actually another document that has all of this publication information, including a native date time. We also have these things called object IDs, which we'll see how those are used in a little bit. So if we're working with MongoDB, the basic design of our application is like this. We have these things called documents. These contain the actual information we want. We get documents from a MongoDB cursor. Each cursor has a collection that it belongs to. Each collection has a database that it belongs to. Every database has a client object, which is what you initialize to start this whole chain of events. And then our application gets the data from the cursor. So it's actually not that complicated. Most of the action, most of the code that you're going to write is calling methods on collection objects. If you don't want to use a cursor, the cursor object has a method called all, which will just return a list of everything that matches that query, or you can use it as an iterator. So let's actually build it, so we can write some code. So here's the guts of our Modulicious Lite application. This is very simple. All we're doing here is setting up a default route, loading a MongoDB module, but we're not actually doing any MongoDB queries. And this is just going to render some text that says hello. So let's actually build something that uses the database. What we're going to do here is we're going to set up a route called /books. And this is basically just going to give us a list of all the books in our library. So first thing we're going to do is we're going to create a new Mongo client object. And I haven't supplied any constructor parameters here. So by default, it's going to try to connect on localhost on the default port. But you can supply parameters there to connect wherever you're hosting your MongoDB database. So the next thing I want to do is I want to ask the client object for a database called library. And remember, databases by themselves don't really do much. They're just namespaces. And then I'm going to ask that database object for a collection called books. And then we're going to do a query. We're going to say collection find. And we haven't passed any parameters to the find method, so this is just going to find everything, right? If in SQL terms, this is the equivalent of select star from table, right? So what we're going to do then is call the render method here for our template, and we're just going to pass in this cursor object right to the template, and we're going to iterate over it to create a list. And this is just a, if you're not familiar with Mojo, this is just an EPL template. Unless you just stick Perl code right in the template in your data section for Modulicious Lite. But it's pretty straightforward. All we're doing is we're iterating on this cursor, just calling next until it returns nothing, at which point the loop will end. And we're outputting a list of the titles of all of our books. So if we actually run this, what we'll get is something that looks like this. In this case, we have 4 books. And that's it. That's all it takes. We didn't have to transform anything out of a relational structure, because the structure that exists in our database is exactly what we already have in our program. So let's do something maybe a little more interesting. So you might remember from our original book example, we had this genre field. And in this case, our genre, we have 2 genres for this book, fantasy and adventure. So what if we want to query books by genre and say, I want a list of fantasy books, or I want a list of adventure books. Well, it turns out that's actually really easy to do. Here's some example code. This might be a little small because I screwed up the image here. But we're setting up a get route for /books/genre. You notice the colon in front of the genre. That just means that's going to be a variable. So we can go to books/fantasy, books/adventure, and that variable will be populated in our stash. So again, we're going to create a new Mongo object. You don't have to do this in every method. You could write a helper that instantiates it for you. But I just did it here for simplicity. We're going to get the library database. We're going to get the books collection. And then we're going to call find. And we're going to say find, and we're going to pass in this hash ref that says genre maps to $genre, which is the value of whatever appeared in our URL. And this does an equality query. This is the way if you want to match a field against a value, this is how you do it in MongoDB. And if you were paying attention, you might say, well, wait a minute, Mike. We're doing an equality query here, but that genre field in our example book was an array, not a scalar value. And I would say, yes, you're right, and good job paying attention. And in MongoDB, when you do a comparison on an array, it's basically the equivalent of doing an in operation. So you're saying, find me documents where the value of this genre variable appears within that genre array. Now the nice thing about this is if genre were a scalar field, if it was just a string there, the exact same query would still work. So that means that if you wanted to, you could have some documents in this collection that have a single genre and some documents that have an array of genres, and they would both be found by this query. Or if you wanted to be more consistent, for books that have a single genre, you could just have them as an array of one item. But either way you want to do it will work. And so again, we're going to pass this cursor to our template. And no, I forgot the screenshot for that, but you can take my word for it. That'll show you a list of all the fantasy or adventure books that you want to see. All right, so let's do something a little more interesting. So far we showed you how to query the database. How about putting stuff into the database? So what I want to do is I want to create a post handler for adding another book. And it turns out this is also really easy. And in fact, this is where things really shine, I think, and you'll see why in a couple seconds. So again, we're going to create a new MongoDB object. And what we're going to do is just create a new book hash ref. And all this is we have stuff that comes right out of the post parameters to our application. So title just comes out of param title, author just comes out of that. For genre, we're going to create an array ref. And people can pass in multiple values for the genre field in the post. So whatever those values are, they'll get returned to that array ref. And remember, the publication information was an embedded document, so we just create another hash ref here. And we say publication, the name, the location, we grab that. For the date, the MongoDB driver supports datetime natively. So we can use datetime or datetime tiny for native date representations. You might want, if you're doing a lot of date stuff and you don't have to do actual date calculations, you can use datetime tiny because datetime objects are really expensive to construct. But that's it. And then we have that new book data structure built up. And then to insert that, it's just this. We just call insert and pass it in. And it just goes in exactly that structure. So that'll go in as that document with the title, author, publication fields. Genre will be an array. It'll be stored as an array in the database. Publication date will be a native date type. That's stored as a native date type in the database. Which means you can use date-based queries on it. And we didn't have to use an ORM. We didn't have to use a middleware layer. We didn't have to use an SQL phrasebook to do this. It just goes right in, and it has the exact same structure that you already use in your programming language. So that's all there really is to it. And like I said, this is a very short, very basic introduction. But let's look at some conclusions. So MongoDB is easy to work with. You don't have to learn SQL. There is a very sophisticated query language, which is pretty well documented. But to get started doing basic stuff, all you have to do is just call methods and pass data structures around. And you guys are all Perl hackers, so you know how to do that already. There are no schema definitions in MongoDB. So Often, if you're working with a relational database, the first thing you have to do before you write any of the fun code is you have to define your database schema, write a bunch of SQL definitions, and do all that stuff. You don't have to do that with MongoDB. There's no command to create a database or a collection. You just name a collection, start inserting stuff, and it works. Now, disadvantage, that can be a little chaotic, right? You could end up with a bunch of documents that look nothing like one another, and that would be bad. So it is up to you to make sure that there is some level of sanity in the documents that you store. But the nice thing is, if you want to have some documents that contain a field and not have that field in documents where it doesn't apply, you can do that, as long as your application is aware of how to deal with that. So there's no relational modeling, and you can do the equivalent of this. You can normalize things and store things in different collections as you would different tables. But at that point, you're basically reinventing the relational database anyway. So if you really want to use a relational database, just use a relational database. In MongoDB, it would be a bad idea to do that because there's no real concept of joins across collections or something like that. So in situations where you would have to do the equivalent of a join, you'd have to do multiple queries against your database, which you probably don't want to do. You probably chose MongoDB because you wanted something that's going to give you everything back really quickly when you need it, and you give up the advantages of normalization in order to do that. This is the most important thing, I think, which is that MongoDB's model matches your code. Right? You all know how to do complex data structures in Perl. You know how to deal with hash graphs. You know how to deal with arrays. MongoDB's structure is exactly like that, which means you can pull stuff out, you have it in a structure that you can work with immediately. You can take stuff that's in your native structure and just push it right in, and you're done. Finally, this is the kind of a more abstract conclusion, but this is what I think it all leads up to, which is that your use cases can determine your data model and not the other way around. Often in traditional application development, we figure out, all right, here are the atomic pieces of data that I need to isolate and normalize. I'll build my relational model around that. If I'm being really fancy, I can prove mathematically using relational algebra that it's the correct schema, and then I can finally start writing code, but that code, the structure of that code is really dictated by the data structure that's been imposed on it. In MongoDB, you don't have to do that. In MongoDB, it's exactly the opposite. You can say, all right, I want to write a web application that's going to tell me this information, so I'll just start writing the web application, and the way that I store data in MongoDB will just fall right out of that. Now, that doesn't mean that you don't have to do schema design. You do. It means that the database is not going to enforce something, but you do have to think a little bit about how you're going to store your data and where things will go. And there are a lot of really great resources about schema design in MongoDB and what to look out for, which I can point you to if you're interested. All right. So if you're interested in learning more about this stuff, check out the manual, docs.mongodb.org. It's really nice. I've been worked at MongoDB for about 2 years, and in that time they have vastly updated and improved the documentation. So it is really very nicely done and covers everything that you need to know. It's really comprehensive. To learn more about the MongoDB Perl driver, there's a pod that comes with a distribution called MongoDB Tutorial. That'll get you up and running pretty quickly. And of course, the documentation on the rest of the driver is very good as well. You can check out the library demo app. Here it is, github.com/fredo/mongo-library. And some suggested features that you can implement is a way to add or edit authors, a way to edit books. We saw how to create new ones, but what if you want to update one. There's also a whole ecosystem of Perl stuff out on CPAN, which you guys can take a look at. We don't have ORMs in MongoDB, but there are some thin, lightweight layers called ODMs, Object Document Mappers. And these can provide a little bit of a sanity check. For example, they can make sure that, if you want to make sure that every document that goes to a collection has a certain bunch of required fields, these can make it easier to do that checking. If you want to make, auto-inflate MongoDB documents into objects, these can do that as well. So one example is Mongoose. This is a port of a Ruby module called Mongo Mapper. And this basically will allow you to define loose objects, which automatically maps documents to objects, to loose objects, which you then get back, and vice versa. So instead of just inserting a raw hash ref into MongoDB, you would create a loose object and tell Mongoose to insert that, and it will go. There's also MongoDBI. MongoDBI gives you kind of a nice domain-specific language, also very kind of loose-ish language to define schemas. And this does a lot of the same type of stuff. It verifies that the fields you want are there, that they're the right type before they go in the database, and auto-inflates stuff into loose objects when it comes out. There's also this cool thing called MongoDB Async. This MongoDB Async tracks the mainstream MongoDB driver, but adds co-row in order to do asynchronous queries. And so it's very cool. And it was unmaintained for a while, and then I think somebody else picked it up and started maintaining it again. So there have been some recent releases. The nice thing about it is you can basically use it as a drop-in replacement for the official MongoDB driver, and most stuff will work. There is also Mango, which is a really nice pure Perl MongoDB driver that's designed for integration with Modulicious. And you can use the regular MongoDB driver with Modulicious too, but this is really nice because it's pure Perl, which means it's easy to deploy. There's no C to compile. Sebastian Rydell, who wrote Modulicious, also wrote this. It is asynchronous and non-blocking, which is really nice to work with, and it is actively maintained. So that is the brief introduction. So if you have any questions, I'll answer them now, or we can move on to the other presentation. All right, nobody wants to know the meaning of life then?
Well, you know,
No,
it
actually,
could,
not interested.
it could be in your second presentation. So.
That's true. It might be. All right. So without further ado, spoiler alert.
It's not in your second presentation.
I'm not going to tell you if it is or it isn't, but
No spoilers.
we'll move on to that. This one, I think, is more interesting. This one gets into a little more about sort of interesting stuff that you can do with MongoDB, and Perl particularly. So this is MongoDB aggregation in Perl. We're going to look at just one sort of subset of MongoDB features, which is the aggregation framework. And the aggregation framework, I think, is probably the coolest MongoDB feature. And we saw in the last presentation, we looked at a little bit about, we saw sort of kind of a preview of the MongoDB query language. We saw how to do a simple equality query, and the query language supports a number of other operators. But in MongoDB 2.2, we added this very cool, you're trying out the QR code. Does it work? I forgot to test it a while ago.
I get a not found from Talks Ag.
No,
But I got the QR code worked, the website. That
it doesn't
messed
work.
up.
Okay, so yeah, that means I forgot to put the web page up. I'll fix that for you though.
I'll be checking on it later on tonight.
Okay, I don't know if I'll do it tonight, but I'll do it soon. This
I'm just
talk, by
kidding.
the way, is still a work in progress. It's kind of a beta. So look for future versions of this that might have some more interesting examples. But I want to talk about what the aggregation framework is, because it works somewhat differently from traditional MongoDB queries, and it works probably a lot differently from the from database operations that you're probably used to. So the way we describe MongoDB aggregation is that it is a pipeline. And if you're familiar, you guys are all Perl hackers, so you know about Unix pipelines. You have something like this. You take stuff from standard input, and it goes to standard output, and it goes to standard input, and it goes to standard output. And you can build up very complex pipelines of this by using the idea of a Unix program as a black box where lines of text go in one at a time and lines of text come out one at a time. And everybody who's worked in Unix for the past, 30, 40 years is familiar with this model. In the MongoDB aggregation pipeline, instead of lines of text, we have structured documents that go in one at a time and come out one at a time. And this is very interesting. And it's a little bit, it's a lot different actually than working with lines of text, but it's also a lot more powerful. So MongoDB, instead of Unix programs, has this set of aggregation operators. And these are a few of them. There are actually a bunch more. But we're going to look at a few of the interesting ones and see how we can build up pipelines of operators to do really interesting things. And we're going to see how we can do this using Perl. So the first example I want to show you is sort of the default framework of how you work with aggregation operators in Perl. So this is kind of the pattern that we're going to see over and over again. And it's pretty straightforward. Basically, we're going to get a collection object. We're going to build up an array of pipeline operators. Each item in this array is going to be a hash ref. So every pipeline operator is basically a MongoDB document. And then we're going to call this aggregate method on the collection, passing in the pipeline array of operators. So what this means is that every document in that collection is going to be filtered through this series of operators, which can be as long as we want. We can have a pipeline of just one, or we can have a pipeline of dozens of operators. So that part is obvious. That's going to load our MongoDB driver. And you remember this from the last presentation. This is basically just how we get our collection object. There's our pipeline, and that's how we actually run the aggregation query. So let's see an example of what we might actually do with this. So the first use case I want to look at is data from GitHub. GitHub's API actually will provide you with tons and tons of data, and it's actually really useful for coming up with database examples because there's just so much available. And they don't care what you do. You sign up for an API token and you can just do whatever the hell you want. They don't limit you, really. So what I wanted to do is I wanted to look at a GitHub project, and I wanted to create kind of a histogram of every user who committed to that project and how often they commit. So in other words, if I have a user on a project, I want to see if this user did 3 commits on this day and 2 commits on another day and so on. And I want to see all of that in a nice graphical format. So our goal is that for every unique user, we're going to create a histogram of commits to a project. So the commit data that we can get from the GitHub API looks sort of like this. And there's a bunch of stuff here. But what we're really interested in is this chunk of it. This chunk of JSON data that says commit, and it has an author. All right, the author has a name, the commit date, and an email address. So really all we need to look at is this little field of 3 items, which is the date of this commit and the author's name. So let's figure out how we might actually get this. And this is a nice bit of Perl hackery. We're going to set up our MongoDB object. We're going to set up some variables here. And we set up this page count variable, because I think I looped through 100 pages of API data. And I think there's 100 events per page. This is like 10,000 events that I've grabbed for this project. So the loop to get this is really simple. I'm just using LWP here. The GitHub API gives you the link to the next page of data in a link header, so I just parse it out there. And then all I have to do is just say the commits data equals the response data run through JSON XS. And then once I have that commits data, I can tweak it a little bit. So one interesting thing is I want to make sure if for some reason this process to download data failed in the middle and I need to restart it, I want to make sure I don't insert duplicate stuff. So the first thing I do is I want to do a query to see if I already have this, this particular information. And you notice this field called _ID. Every collection in MongoDB, or every document in MongoDB has to have an _ID field. That serves as your primary key, and it has to be unique within that collection. So what I did is for the underscore ID field, I just use the SHA-256 code from that GitHub commit. So every Git commit has a unique SHA code, and I just use that as the ID. Now, if you don't supply a unique ID, MongoDB will create one of a special internal type called object ID, and we saw one of those object IDs in the last presentation. And you can use object IDs here. Since I have a convenient unique identifier, I decided to use that anyway. And the reason I use that is because that makes it easy to check if I already have it. I call this find1 method, which is the same as find, except it just returns the first document that it finds, which matches the query. So if we already have that, I can just skip this iteration of the loop, and that allows me to do resumes if for some reason something fails in the middle of it. The other thing that we have to look out for is I want to make sure that the dates in my MongoDB document get saved to the database as actual MongoDB date types. JSON doesn't have a date type, and if you remember from that sample data we saw, the date is just stored as a string, right? Because there's no date type in JSON, so that's what you have to do. So what I do here is I just regex out all the information from that date string, and then I create a datetime_tiny object, just passing %+ to the constructor. %+ stores the named captures from your regex. So that makes a nice datetime_tiny object. Datetime_tiny can't do any date math like datetime can, but that's fine, because I just want this in a datetime object so I can insert it into the database. So then to insert it, all I have to do is that. Doesn't get any easier than that. All right, so now we've fetched these 10,000 events from GitHub, so now we have a database. And when we have a database, we can ask it some questions. So the first aggregation operator I want to show you is called project. And if you look up project in the manual, it says it reshapes the document stream and can rename, add, or remove fields, as well as create computed values and sub-documents. I don't really know what that means entirely, but if you play with it, I can show you some examples to see how it works. So here's what we're going to do. We're going to create a pipeline which has 2 stages. The last stage is this limit operator, which says limit 5. And this is just for testing because I don't want to dump thousands of documents every time I tweak this query. I just want to see the first 5. So when we're ready to use it for real, we'll remove the limit.
Question.
Yes?
If you have that limit 5 pipeline or element in your pipeline, will it stop the whole pipeline when it reaches that limit, or does the first thing still process everything?
So the question is, if we have a limit, will that stop processing the pipeline once the limit is reached, or does it process everything and throw it away? I believe it stops processing the pipeline. The aggregation query optimizer is fairly smart, although not as smart as it could be. But in the case of a limit, once a limit is reached, it should stop processing it. So now, you notice MongoDB, unfortunately for us Perl guys, uses the $sign in its query language quite literally. So query operators are prefixed with a $sign. Aggregation operators are prefixed with a $sign. In addition, certain values are prefixed with a $sign, and the $sign means a different thing in certain circumstances, which I'll explain in a minute. So you notice our aggregation operators here are called $project and $limit. I have those in single quotes, so I'm passing, so I'm passing the literal string $project to the database. In our project document, we have this subdocument, which has these 2 fields, author name and author date. And what project does, or one of the things it can do, is it can reach down into deeply nested data within your document and create new fields out of that. So what this means is on the right side of these maps, we see on the first one it says $author.name. So what that means is that's basically MongoDB syntax for the value of the field name in the document called author. So remember, author mapped to a sub-hash, right, which had a field called name. So this just means reach down to that object, grab the value of the name, and pull it out. And that's going to exist in our projection in a field called author name. Similarly, author date, in this case, our date value was not in a subdocument, it was at the top level. So we're just saying value of date. And this is a very simple projection example. But what this means is that when we run this project step across that commit data, remember that commit data was a large JSON object, had a lot of fields. All we're going to get back is these two fields, the first one of which has been pulled out from deep structure into the top level. And then that pipeline is going to get passed to our limit step, which will limit it to 5. I'm using data printer here to print out the results from our aggregate query. If you haven't used data printer, I highly recommend it. So our pipeline looks like this. We have our commits data, we have our project step, which is going to extract our name and date from those JSON objects. We're going to stop after 5, and we're going to get some results. And the results look like this. So here are 5 of them. Remember, the underscore ID is our get SHA hash. We have our author date coming out in native Perl date time, which is nice, because the driver knows that this is a MongoDB date object, so it does that automatically for us. And we have our author name, which just comes out as a regular string. So we're on our way. Now we have the information we need. We have our date, and we have our authors. So what that bit of technical nonsense from the manual means is that project can reach into embedded documents and pull data up. And this is really useful for simplifying queries. When you have like a really complicated document structure in your collection, you can use project to just pick and choose the bits that you need and basically get a new single level document out of that stream. All right, but we're not done yet. We don't have a histogram yet. So our next problem is that we need to extract the days from these date values, because those are actual date time values, right? It's day, month, year, and the time of day. And if we tried to just group on that, we'd end up with a histogram that went by the second. That's not very useful. We want a histogram that goes by the day. So we need to extract those actual days. And the way we can do this is we can use project again. And this is actually not the most efficient way to do this, but it's I think, the simplest way to demonstrate it. The nice thing about project is that project comes with a number of sub-operators for grabbing stuff out of individual bits of data. And when dealing with datetime data, it comes with these operators, which can grab the pieces out of date. So now you see why it's important that we store these dates as native MongoDB dates and not just strings that they came back with as JSON. Because if they were strings, then it would be much harder to do this. There's some limited string operations in MongoDB, but it's much easier just to have them as data dates. So let's look at our new pipeline. Now it's going to look like this. So I've added a new phase in the middle. And you see this is where project starts to get kind of interesting. So what we have here is we're going to combine our author name and author date into a new document, which is going to extract year, month, and day by using these year, month, and day functions on the value of author date. The thing that's interesting about this is that author date is not a field that exists in our original document. Remember, that field was created in the first project step. Right? So that's actually, this sort of demonstrates what's really interesting about MongoDB pipelines, is that you're creating new documents as they go through each phase of the pipeline, and then each phase of the pipeline is dealing with those dynamically created documents, not the original stuff that was in your collection. So what this does is this is a second project phase that's just creating a single field, author and date. The documents we'll get out of here will each have a single field called author and date. That field will itself be a subdocument containing a field called author. And again, remember, dollar in this context, dollar author name means the value of author name, which was a field created in the first project step. And then it'll have the fields year, month, and day, each one of which is the value of this function. Dollar year extracts the year from author date, dollar month extracts the month, and dollar day of month extracts the day of the month. So now what we'll have is a stream of documents that have our year, month, and day as structured elements, and also includes our author name. So our pipeline now looks like this. There it is. We have our commits. We have our first project step to extract the name and date. We have our second project step to extract the days from the dates. And we have our temporary limit step, and then we get our results. So what we get out of this is a thing that looks like this. So again, our ID, by the way, our ID comes through by default, even though we didn't project it. That'll always be included. You can turn that off if you don't want it, but it's just there by default. And the other thing we have is this author and date field. And so now this has information that looks a little more useful for creating a histogram. So we have this author, Greg Studer, and we have the day, month, and year. We don't have the time information anymore because we didn't include it in our projection. So the conclusion we can draw from this step is that project can create embedded documents that are computed from values in the previous pipeline stage. So project is a really powerful operator. It can do all sorts of interesting things. But we're not done yet. We have our author and date, but we don't really have histogram data because we don't know how many commits each person made on each day. We just have a stream of documents, one per commit, that contains the author and the date. So we want to aggregate events occurring on the same day. And this is where we get to use the other really super powerful aggregation operator, which is called group. And if you look group up in the manual, it says this: it groups documents together for the purpose of calculating aggregate values based on a collection of documents. And I don't know what that means. So let's look at an example. So here, I've taken away the limit step now. So we just have 3 steps now, and the last one is group. And what we're going to do is, the way group works is that you have to specify a new underscore ID, which would be the unique value for every document coming out of this group operator. So what we're doing here is we're saying, I want the unique ID of every document coming out of this group operator to be the value of author and date, which is the field computed in our second project step. Now remember, author and date is actually a sub-document, but that's okay. IDs can themselves be documents, and as long as each one is unique, it's okay. So what this is going to do is it's going to say, all right, I want to find the set of documents that has this author and date field, and I'm going to include that in one group. I'm going to find the set of documents that has a different author and date field and include that in a second group. So what we're going to end up with is we're going to end up at the other side of this group operator with one document for every unique combination of author, day, month, and year. And that'll be able to give us our count for commits per day. And the way we do that is we use, we're going to create a new field called total in our group, in our output from the groups. And we're going to use this $sum operator. $sum operator works very simply. It's just going to add whatever the right side value is to the other values in that group. In this case, we're just adding 1 for each document that we see. But we could add another number, or we can add the value of a computed field from a previous stage in our pipeline to do our really interesting things. In this case, we're just adding 1. So this is it. So now our pipeline looks like this. There's our commits collection, our first project, our second project, our group, and that's going to give us our results. And I've taken the limit away. So what we get is actually a few thousand results, but a few of them look like this. So we have this ID field, and see the value of our ID is just that author date field that we created in the second project. But now we have this total field that gives us the total number of documents that have that same author and date combination. So now we have a histogram. We can see how many commits each person made on each date. So that we can conclude from that is that group makes new documents by aggregating values. All right, any questions thus far? Okay. So this is a Perl Mongers group, right? So let's write some Perl. So what we're going to do is we're going to create a histogram using this data. So we're going to run aggregate on our pipeline. We're going to get an array ref back of results. And these are going to be all of the result documents that I showed you a couple of slides ago. So we're going to loop over that. And what we're going to do is, I just want, for the purposes of this, just to get commits this year, 2014. So I'm just throwing away everything from prior years. And I could have just thrown that away when I did the fetch, but I figured I wanted to get more data in case I want to do different aggregations later. So the next thing I'm going to do is I'm going to create a datetime object out of the year, month, and day information that I got out of this group operator. Because remember, we extracted the year, month, and day, which are just regular integers now. So now I'm going to create a datetime object, and I'm going to create this hash. And the first level of this hash is the author, The second level is an array, which is just going to be from between 0 and 365, which is the day of the year. And the value of that is just going to be the total. So what I'm left with is a hash of authors, which have an array of days. The value, which has an array where each index is a day, I should say, and the value of that array element is the total number of commits for that day. And 2014 is only like half over, so only half that'll be populated, and this will continue to work for the whole year. So I created a HTML table here, and I just chose this arbitrary mapping to generate a color from the total commits value. And what you get is something that actually kind of looks kind of interesting. So here, this is just a portion of the table, because there's actually a lot of committers. We can see darker colors here mean more commits per day. And you can get a really good picture right away. From this, you see some people have hardly any commits. Some people work on the kernel a lot, like Elliot Horowitz there, who basically all he does. And so they have a lot of days with lots of commits. Other people have just a few commits with nothing in between. And so it's interesting. So that's the sort of thing that you can do with the aggregation framework. That's the sort of sensible thing that you might do. But maybe you want to do something a little ridiculous. So this is an example that I found on the blog of a MongoDB employee named John Page. And John's a really interesting guy. And he was working on an aggregation example for a different blog post. And he realized he needed to take the square root of some numbers. So he said, all right, well, I'll just use the square root operator, right? We had the sum operator, and there's other arithmetic operators. So he tried it, and it didn't work. And he looked in the manual, and to his horror, he discovered there actually isn't a square root operator in the MongoDB aggregation framework. This must have been an oversight, or just, I don't know, someone was too lazy to implement it. So you can add, subtract, divide, and multiply, but there are no square roots. So our goal for this is for every document of the form n maps to some number, we want to find the square root. And we're going to do it using Newton's method within the MongoDB aggregation framework. So I love the facial expressions every time I do this, because why would you want to do this? Well, there's no good reason for it, other than just it's kind of fun to see what this can do. You would never use this in real life, of course. In real life, you would just use the square root function in your programming language, because it's going to be a lot faster than doing iterative numeric calculation. But let's see how this works. So for those of you who have forgotten all your math, like I have, to review Newton's method, if you want to find the square root of a number, you set up a function, quadratic equation like this, x squared minus 42. You find the first derivative of that function, which is a really easy derivative, guys. Nobody? 2x, okay, good. I was getting worried. All right. So we find the derivative of that, and then we iterate this function where we say x sub n plus 1 equals x sub n minus f of x sub n over the derivative at x sub n. And that is Newton's method, where x sub 0 is some initial guess. All right, so, and we can, to get to the answer quickly, if we can make an initial guess that is close to what we think the square root will be. But for simplicity, we're just going to use the same initial guess for all of them. And as it turns out, Newton's method actually converges fairly quickly, so it works fine if we're doing it by computer. If you're doing it by hand, you would want to come up with a more intelligent guess. But this is what we're going to set up. We're going to set up we're going to set up two hash refs here, which are going to represent the stages of our aggregation pipelines. The first one is going to be called first guess. And all we're going to do is we're going to say first guess is going to project a document where the field n is included. So this projection where it says n equals 1 is basically saying include the field n from our original document. And we're going to create a field called r, and the value of that field is going to be the literal value 1. So that's going to be our first guess. We're going to use 1 as the first guess for all of our square roots. The second stage is the iterator stage that I showed you before. And we're going to call this refine. And what this refine is going to do is it's going to do another project where again it's going to say include the value of one, include the value n, whatever our number is. And for r, we're going to do this arithmetic, which is just basically calculating the special case of Newton's method for square roots. And you can confirm that this arithmetic is correct. The way to think of this is it's RPN in Perl data structures. All right. Any Lispers among you should be right at home here, or fourth programmers. All right. So let's see how we're actually going to use this. What we're going to do is we're going to create a pipeline, and the first element of our pipeline is going to be this first guess thing, which all it does is it extracts the value of this field n, and it creates this first guess value. And the second stage of our pipeline is just going to be the refine step 8 times. And I chose 8 just because that works. And if you keep doing it more, you still get the same answer. But 8 is enough iterations to get the correct answer for all the numbers that I tried. And then we're just going to run this pipeline. So the cool thing about this is we're just repeating the same step in this pipeline over and over again to get the value out. And what we get is stuff like this. So for n equals 62, r equals 7.87, 63 is 7.9, 64 is 8. It works. Those are the right square roots. So that's a ridiculous example. You would never do that in real life, but I enjoyed it so much that I like to present it. And it really demonstrates what you can do, because a lot of people don't think about the idea of, hey, I can create an aggregation pipeline and just use it over and over again by just passing a bunch of copies of it to the aggregate operator. So the final conclusion for this is the MongoDB aggregation framework is really cool. And I like it a lot. It's by far my favorite feature of MongoDB. I think it is incredibly and uniquely powerful. And I think these two examples really show you sort of what you can accomplish by coming up with ways to chain these aggregation operators together in new and interesting ways. And these presentations really only barely scratch the surface of what you can do in aggregation. So that's it, and thank you very much for inviting me out here.
Well, thank you. How recent is that aggregation framework? Is that
So the aggregation framework, I believe, was introduced in MongoDB 2.2. The current version of MongoDB is 2.6. We use the even numbering system where even numbers in the middle are production releases. So the current development track is 2.7. And 2.8 will be released in probably, I think they're currently targeting early next year.
So 2.2 was a few years ago?
Yeah, so 2.2, the 2.2 release, I think, was like around September of, 2013 or something like that.
Okay.
It was
It's been a couple of years since I used it.
Yeah.
Probably
So-
wasn't there then.
Yeah. So 2.2 was a big release, and that included the aggregation stuff as well as a bunch of new features as well. So the aggregation framework has matured quite a bit. In 2.4, a bunch of new operators are added, and there's a few more still in 2.6.
Are they going to add the square root?
It's a good question. I don't know.
Here's another question
yeah.
along the same line. Can you embed Perl code into there? So like, could you use the Perl square root function?
So you cannot send Perl code to the database.
That's what I figured.
There is, not within aggregation, but we do have a way to execute arbitrary JavaScript on the database server. Actually, there's a couple ways to do that. One is just through regular queries. One is through the MapReduce framework. So if you want to do execute arbitrary code, you can create MapReduce queries that do it. For aggregation, you can't execute arbitrary code, but the nice thing is that you can build up these data structures in such a way that you can end up with fairly complex dynamic aggregation query, because it's just an array of hashes, right? You can build that up in a way that you can do really interesting stuff. So you saw in that example, I just duplicated that refine step 8 times using x8. But you can end up doing programmatic things that generate very complex data structures to do stuff in aggregation. So one of the projects I'm doing just as a demo, which I haven't started yet, but I thought about it a lot, is I was kind of inspired by this, doing numeric computation with the aggregation framework. I figured, well, what if could we do symbolic computation using the aggregation framework? So I have a system of a bunch of functions that I set up just to store things like rational numbers and complex numbers, and then aggregation operators that use the arithmetic primitives to do complex arithmetic, and to do like really simple equation solving, representing polynomials as like arrays of values and things like that. And again, that's a ridiculous example. You would not want to do symbolic computation in the aggregation framework. But I just think it's so fun to play with that I come up with stuff like that. Cool. All right, any other questions? All right.
Do you tend to end up with, like, I don't know, some industry or some problem spaces that tend to jump into Mongo a little more commonly than others?
Sure. Well, what we're starting to find out is that a lot of people who are dealing with really massive data sets who need access to the data fast are starting to use MongoDB. So one of our, we have a white paper somewhere, one of our success stories that we like to promote a lot is MetLife Insurance. And what they did is, they've been around forever, right? They're over 100 years old. Their corporate history goes back a very long way. And much of their business was built on mainframes in the 60s and 70s, running relational databases. And because of all their different divisions and acquisitions over the years, they had several dozen different systems in different databases, different mainframe architectures. And what they did for their customer service department is they basically ran an ETL job and just extracted everything out of all these systems, dumped it all in MongoDB so the customer service reps could get a single view of everything about a given customer. And the reported efficiencies that they gained in their customer service department were completely mind-blowing. They were talking about the length of an average call decreased by like 300%, and the customer service reps were able, to handle, multiples more calls than they used to be able to all day. Their customer satisfaction numbers started going through the roof because someone can call and say, all right, I have a question about my auto policy and my homeowners, and so forth, and all this stuff. Where previously they'd have to talk to 6 different divisions, and now a single customer service rep could just see it all in one place. And that's not really an example of aggregation. That's more an example of like ETL and data warehousing applications. But they did that application and they developed it in like 4 months, and they just deployed it and it transformed their business. And this is a 100-year-old insurance company, which you don't expect you often don't hear about companies like that using sort of disruptive technologies like MongoDB. So that I think was a really interesting example. In terms of aggregation, a lot of people are doing stuff in financials, the sciences, a lot of interesting bioinformatics stuff is using MongoDB aggregation.
That was one of the ones I was wondering if it was going to be on the,
I'm
top of your list.
I'm not an expert in that stuff, so I can't really talk intelligently about it, but I know it is going on. So it's
the BioPearl work that used to be more common in the industry 5 years ago. It was very, very similar to your aggregations.
Yeah, well, BioPearl was just like a bunch of pipeline tools.
Yeah.
Same kind of idea.
Yeah.
Except now you can do it within a database.
Yeah.
And the pipeline tools are a little more sophisticated because they work on structured documents instead of just lines of text. Yeah.
Less awk.
Less awk, more projected group.
So what user security is it for?
So user security, so we have an authentication mechanism. Older versions basically just supported name and password. Newer versions support Kerberos authentication, some other what else, LDAP. But if you don't want to do that stuff, you can just store basically user objects within the database, and you can configure permissions. You say this user has read-only access to this collection, and they have read-write to this collection. And so there's a pretty robust permissions model, you can say.
Cool.
Inspiring.
All right. Thanks. Well, I love to hear people who try it out, so please let me know how it goes.